Oh my goodness. You guys are not going to believe this. This is the third time I have recorded this. The first time my computer froze. The second time I was on mute the whole time. So it's a good thing my lucky number is lucky number 3, because here we go. So you guys just finished working on your entry task. All right. And so what I need you to do is everybody needs to grab out page 288 through 290. I'm going to quickly run through what the correct answers are. You are still going to show me these answers on, or you're still going to show me your books on tomorrow. Okay. So you're still showing me all of the information that you need to show me tomorrow. Got it? Okay. So and remember, no work, no credit. So don't try to really quick copy these answers down, because what I'm going to tell you is that if you don't have the work that goes behind it, you will not be getting credit for it. All right, so here we go. So this problem right here, what we know is these are all of his scores for each round. And then during the 5th round, he doubled his overall score. So what we did first is we added together all of his points. Notice that I added my negatives and my positives, and then I added them all together. And so the total points for the first 4 rounds was 85. Then I doubled it because it says that his 5th round was doubled. And so it comes out to be 170 points. Okay. Next, number 3, we're looking for keywords. 14 3/10 below, she's scuba diving, and then she swims down. So that's also a negative 5 8/10. But then he swims up 3 2/10. The best part of this whole problem is this word right here where it says approximation, because I get to round these. So negative 14 3/10 is negative 14. Negative 5 8/10 is negative 6. Or 3 2/10 is 3. So if I add these together, I end up getting negative 17 meters. Okay. Number 5. Okay, which of these situations would give me an approximate estimated answer of negative 7? Well, this one says that the temperature falls about 2 degrees from 4 degrees. So 4 minus 2 is 2. B, the hot air balloon rises 4 1/10, so that's about 4. And then it rises 2 3/10 more, so that's 2 more. So that's a total of 6. C, a submarine dives 3 8/10 feet below, so that's about negative 4. Then it dives, so that's going down still, another 2.5 feet, so that's about negative 3. Winner, winner, chicken dinner. That's about negative 7. Lakita has about $4, and she spends $2.45, so that's minus, so it comes out to be $2. Number 6, okay? Using these numbers in here, which would give us the greatest sum? Well, obviously your 2 positive numbers. Which would give us the greatest difference? Your largest positive and your smallest. So 11 1/4 minus a negative 20 8/10. The greatest product, we're looking for either 2 positives or 2 negatives. And the 2 negatives win because this number is pretty big. So negative 5.5 times negative 20 8/10, all right, is your answer. And the greatest quotient, again, you're either looking for 2 positives or 2 negatives. And this one right here, negative 20 8/10 divided by negative 4 is it. Last but not least, number 8. So she deposits, which was a positive, into her account, 4 checks, and each check is $125.25 for a grand total of $501. Then she makes 4 withdrawals. All right, so 4 times 45 comes out to be 180. And then she takes 1 more withdrawal of $400. So we subtract 400. So if I solve this problem, it comes out to be a negative $79. All right. So those are your answers to yesterday's homework. I just wanted to go through those with you really quickly. But what we'll do is when we're back in person and I'm here on tomorrow, all right, I will check those answers with you. Okay. All right. So let's talk about what we're talking about today. So today's lesson is all about something that's be honest with you guys, I'm really good at the distributive property right now because this is the third time I've gone through it today. All right, so the distributive property, here we go. All right, what if I told you, I asked you to solve this problem, and a lot of you guys are like, finally, Mrs. Parkin's doing what I've been wanting to do forever and ever and ever, which is multiplying numbers without having to show my work. Woo! All right, so what if I told you and asked you to multiply these numbers without using any work? Okay? All right, so a lot of you guys would do the air multiplication. So in the air, you go 97 times 8, and then you would do all your carrying and all that stuff. But what if I told you that there's actually a way to make this happen that's actually pretty easy, okay? And what we have to do and what we're going to do is we're going to take, this is wonderful, just a second. So what we're going to do is we're going to take this number right here and we're going to break it up. We're going to rip it into two parts, okay? So if you think of 97, one way to get 97 would be 90 plus 7, right? And if you think about it, multiplying numbers that end in 0, pretty easy stuff, right? Or another way to get 97 is 100 minus 3. Both of those work out to be 97. So look at what we're going to do. Excuse me. First thing I need to remind you guys is that whenever you have a number next to a parenthesis, it's multiplication. So this is really 8 times 90 plus 7. And what we're going to do is we're going to multiply the 8 times the 90. We're going to multiply the 8 times the 7. So this is really 720. This is really 56. And finally, we get our answer of 776. Or you can use this. Break up 97 that way, which is even easier. So this would be 8 times 100 minus 3. Well, 8 times 100 minus 8 times 3 gives us 800 minus 24. Guess what? 776. So what I did is I broke up that number inside the parentheses into two numbers, and I just multiplied that outside number by everything on the inside. Okay, that's how I got it. All right, this right here, what we just did is called the distributive property. This property is used when you have a problem that involves either multiplication and addition or multiplication and subtraction, right? So look, this one was multiplication and addition, and this one down here was multiplication and subtraction, okay? All right, so that's when we use the distributive property, when we get problems to solve that we have to solve that involve two operations. Okay, all right, so to distribute, it means just like that, to distribute. So right now, the big hubbub that's going around is the distribution of COVID vaccines, right? You hear that on the, if you ever watch the news, or maybe your parents talk about that. And what that means is they are giving they're giving different people the vaccine. They're distributing it with everybody. Okay, back in the old days when I was a kid, there was something that was called a paper person. Okay, normally it was like a paper delivery kid, right? And so they'd get on their bikes and they'd ride their bikes around the neighborhood and they would deliver paper to every house. They distributed the paper to every house. All right, so when we distribute in math, we are distributing this outside number with each term on the inside. So this outside number with each term on the inside. Okay, and when I say distribute, I mean multiplication. All right, so let's take a look. So this is the biggest mistake that students make. They get this problem 8 times 100 minus 3, and they end up simplifying it down to 800 minus 3. What happened? What happened here? Dun, dun, dun. What did they do wrong? Oh, good answer. You're right. So they went ahead and they distributed the 8 times 100 to get 800. But they should have distributed the 8 times the 3. So instead of getting 3 here, they got 24. They should have gotten 24. So they didn't distribute to both terms. I'll tell you what a term is in a minute. In the parentheses. Okay? All right? This is a term. This number right here is called a term. And that number right there is also a term. A term can be numbers, it can be variables, or it can be a number and a variable together. It's a term. So that's what they forgot to do. All right, so now you know me, and you know that I always try to think of something quirky to help you remember the distributive property. Here's my quirky way of remembering. All right, here we go. So there's a house. Inside the house, there's 2 friends hanging out. They decide to make grilled cheese sandwiches. Yay! They love grilled cheese sandwiches. Grilled cheese sandwiches are good. Well, guess what? The cheese melted on the grill and oh no! Fire, fire, fire! So woo, woo, woo! Here comes the firemen to save the day. Now, if you know a fireman, or if you know a fireman, or you know anything about firefighting, you know that one of the rules that they probably tell their firemen is that when they go into a burning house, they save 1 person at a time because they got to get themselves out safely as well. So they go into the house and they save the first person. Woo! Crowd goes wild. But then they go back into the house and save the second person in the house. So look, the fireman represents the number on the outside. The first person represents the first number, and the second person represents the second number. So 8 times 100 minus 8 times 3. All right, and I'm showing you that because sometimes you'll hear me if you guys get going on your assignments, and if you make that error, I'm going to say, uh-oh, did the fireman save both people? All right, so it's just a way of remembering. So here's another way to remember, another quirkiness. All right, so we have a pitcher. Okay, here. Here's a pitcher of lemonade. We pour the lemonade into 2 cups, right? Okay, but it's super soaked. And then we pour it into there. But guess what? It's super sour. So we take the sugar and we distribute the sugar, the same amount of sugar, into each cup. So they're nice and tasty and sweet. So again, just 2 dorky ways of remembering the distributive property. Now, like I just told you, sometimes your terms aren't just numbers, are they? Nope. Sometimes they're variables. So let me tell you, let's say that I gave you this problem and I said, okay, solve it. And you're like, Mrs. Parkin, we can't. I'm like, why can't you? And you say, because we don't know what X is. I'm like, alrighty then, simplify this. So what you're going to do is you're going to get this into its simplest form. So if you look, ready? I'm looking at this. I see multiplication and subtraction. Oh, ding, 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 ding. I see multiplication, oops, sorry. I see multiplication and subtraction. That means I need to distribute. So bottom, bottom. So 2 times x minus 2 times 4. See, I distributed the 2 with everything on the inside. 2x is 2x. 2 times 4 is 8. And I'm going to circle that because guess what? Winner, winner, chicken dinner. You're done. There is nothing else you can do to this because these right here are called they're not like terms. One has an X behind it. The other does not. So you cannot put them together. Okay? So that's your answer. You're done. You've simplified it. All right? Take a look at this one. Okay, so here we go. Write this problem down. So at least you guys have some notes. So write this problem down. 3 times x plus 8. 3 times x plus 8. All right, so here we go. This again is multiplication. So bottom, bottom. So it's 3 times x plus 3 times 8. So my 3's are the same, right? So 3 times x is 3x. 3 times 8 is 24. Done. Nothing else you can do. All right, you just simplified it. Congratulations. All right, here we go. Whoa, look at this one. Now, we have a little problem. Sorry, whew, that I lost it. Okay, when we distribute this, we're distributing a negative. So it's negative 2 times x plus a negative 2 times 4. Negative 2 times x is a negative 2x. Negative 2 times 4 is a negative 8. Done. Or this is the same answer. Okay? All right? Either or. Those are your answers. Either or. And can't combine them because they're not like terms. All right? Okay? So, again, I know I'm going through this really quickly, so there might be a chance that you might have to rewatch this video again to really understand what it's talking about. All right? So here we go. Wow, man, look at this one. So here we go. Bottom, bottom. So it's negative 3 times x minus negative 3 times 4. Well, negative 3 times x is negative 3x. Minus negative 3 times positive 4 is a negative 12. All right? Now, people, look at this. Duh. U-G-L-Y. It ain't got no alibi. It's ugly. Yeah, it's ugly. So let's make it pretty. To make it pretty, we're gonna keep change. Keep change, right? So here is your answer. Okay? So just be aware that sometimes when you get your final result, you gotta make it pretty. Okay? Last example. All right? Oh my goodness, what the heck? Mrs. Parker, there's no number out there. There's just a negative sign. Well, what's the invisible number? You're right. There's an invisible 1. Okay? So, bottom. So, it becomes negative 1 times x plus negative 1 times 3. Negative 1 times x is negative 1x. Negative 1 times 3 is a negative 3. Or this. Either answer works. Okay? doing. In-person people, you guys are getting the paper copy of the worksheet. All right. If you're on Zoom right now, okay, if you're remote, your worksheet is posted in classwork under Google Classroom. It's called distributive property worksheet. Okay, if you get this done, then you can get a Chromebook, and some of you, there's quite a few of you that need to catch up on your iReady minutes or lessons. All right. The other option that you can do is this. Get on Skyward. Look at your grades, people, because all of the worksheets are all posted in Google Classroom. All right, so you can just get going and work on those things that you need to get turned in. Because guess what? Tomorrow, it's progress report day. So all of my grades are due. So it would be helpful to have some of those assignments turned in. All right, you guys will need to be on your very, very, very best behavior. Okay, don't be talking, don't be walking around, don't be doing any of that stuff. And we will see you guys tomorrow.